Okay, so now we will discuss Module 6, which is about linear programming. So first, yung basic concepts of linear programming. Linear programming is a widely used problem-solving method. The LP problem is to determine the optimal value of a linear function, which defines the objectives of the problem subject to a set of linear constraints. The constraints define the limit or decision environment of the problem. The term optimal may mean maximizing profit or minimizing cost in a specific context. Linear programming models are used to assist people and organizations in making decisions. So pag meron kang linear programming model, so ito yung properties niya. First, yung objective function is to be optimized by either maximization or minimization. So usually it's maximizing profit or pag nagmi-minimize ka ng cost. Number two, second property, there are constraints restricting the activities that are required to carry out the objective. Halimbawa, pag yung supply mo limited lang, so that's example of a constraint. Or kapag yung manpower mo konti lang, pwede mong gamitin yun na constraints. Third, all equations are linear. So lahat ng equations natin dito ay nasa form lang ng mga lines. And number four, the activities or decision variables are generally non-negative. Okay. So to illustrate these properties, let's consider the following example. Suppose that a manufacturer of candies wants to maximize his or her profit by producing two flavors, chocolate and caramel. The manufacturer knows that the net profit of producing chocolate candies is 0.25 per piece, while the net profit for producing caramel candies is 0.30 per piece. The manufacturer's objective function, then, is to maximize profit from the production of the two flavors. Okay? So, kung yung profit mo ay 0.25 for chocolate candies tapos 0.30 yung sa caramel. So, since profit siya, ang gusto mong mangyari, mataas yung profit mo or yung kita mo. So, yung objective function natin dito is to maximize the profit. Okay? So, yung profit natin, which is Z, is equal to 0.25 times yung number nung chocolate candies plus 0.30 times yung number nung caramel candies. Okay? So, yung X and Y dito, ito yung mga decision variables natin dun sa model na gagamitin. Okay? So, kung wala tayong constraints dito, ang most likely na mangyayari, mas marami kang gagawin na caramel candies kasi mas mataas yung profit niya. Okay? Pero in reality, hindi ito laging nangyayari kasi magkakaroon tayo ng iba-ibang restrictions or constraints. For example, magkano yung puhunan mo, yung mga gamit mo, yung mga gagawa ng candies, for example, dito. So, for example, suppose the manufacturer has only at most 20 kilos of flour to produce the candies and that 3 kilos of flour are needed to produce chocolate candies and 4 workers are needed to produce caramel candies. Okay? So, yung restriction natin dito or yung constraint natin, so 3x plus 4y is less than or equal to 20. Ibig sabihin, meron ka lang 20 kilos ng flour. Tapos, sa paggawa ng chocolate candies, 3 kilos. Tapos, sa paggawa ng caramel candies, meron kang 4. Okay? So, ang mangyayari, hindi ka pwedeng lumampas sa 20 kilos kasi yun lang yung meron ka. Okay? So, now, yun. So, the inequality means that each chocolate candy produced requires 3 kilos of flour, while each caramel candy produced requires 4 kilos. And the total kilos of flour used in manufacturing the candies cannot exceed 20 kilos. Okay? Yan. So, yan yung isang constraint natin. Okay? So, take note that yung objective function natin and yung constraint ay parehas na linear. And finally, pwede tayong mag-add ng other constraint na non-negativity constraint para lang i-make sure natin na yung variables natin ay positive. So, hindi naman tayo pwedeng magkaroon ng negative number ng candies. So, to summarize, yung LP model natin for the example, so yung objective function is to maximize Z, yung profit, is equal to 0.25x plus 0.30y. Subject to, ito yung mga constraints natin. So, yung constraint natin ay dalawa lang. So, 3x plus 4y less than or equal to 20. So, ito yung sa ingredients. And non-negativity constraint. X is greater than or equal to 0 and y is greater than or equal to 0. Okay. So, yung paggawa ng LP model natin, halos same lang siya doon sa na-discuss na before na problem-solving strategy. That is to understand kung ano yung mga kailangan mo doon sa model mo. Okay? So, first, so meron tayong steps dito. First is to know the objective and objective function of the decision maker. So, it's either maximization or minimization. So, yung i-optimize mo. Next, kailangan alamin mo yung decision variables mo. Okay. Number 3, kailangan mong alamin yung mga coefficients ng decision variables doon sa objective function. Number 4, kailangan mong alamin yung mga resources mo. So, dito na papasok yung mga capacity, yung resource capacity. Number 5, know the technical coefficients that give a link between the decision variables and the resources. So, yung technical coefficients, sila yung magde-define kung gaano kadami nung each resource to produce a unit nung decision variable. And number 6, isa-set up mo yung mga constraints. So, yun yung mga kanina. Okay? So, para mabuo yung model. So, tingnan natin itong example. A calculator company produces scientific calculators and graphing calculators. Long-term projections indicate an expected demand of at least 100 scientific calculators and 80 graphing calculators each day. Because of limitations on production capacity, no more than 200 scientific calculators and 170 graphing calculators can be made daily. To satisfy a shipping contract, a total of at least 200 calculators must be shipped each day. If each scientific calculator sold result in a 20 pesos loss, but each graphing calculator produces a 50 peso profit, how many of each type should be made daily to maximize net profit? So for this example, kailangan lang natin yung model. So ano yung mga kailangan natin? So first, yung objective function natin. Ano yung gusto natin gawin dito? So gusto natin na i-maximize yung profit natin. So ano ngayon yung ang mga decision variables natin. Okay? So, gaano karami yung kailangan natin gawin na mga or kailangan natin i-produce na calculators. Okay? So, let lang natin na X yung number of scientific calculators. Tapos, yung Y yung number of graphing calculators. Next, ano yung mga decision variables natin? So, anong sabi dun sa problem? So, first, hindi tayo pwedeng lumampas sa 200 na scientific calculators and 170 na graphing calculators. Next, kailangan yung i-ship each day ay at least 200 calculators. Then, yung scientific calculator, yung profit niya is actually 20 pesos loss. So, negative yung profit natin kay scientific calculator. Tapos, yung kay graphing calculator, meron tayong 50 pesos na profit. Okay? So, yun yung mga decision variables natin, tsaka yung mga resources natin. Okay? So, kapag alam na natin yun, i-translate lang natin siya into equations. So, para ma-set up natin yung constraints natin. Okay? So far, yung constraints natin dito, yung scientific calculators, yung X ay at least 100 yung demand. Tapos, at least 80 yung kay graphing calculators. Tapos, hindi ka pwedeng lumampas sa 200 na scientific calculators. Hindi ka pwedeng lumampas ng 170 na graphing calculators. And kapag kinombine mo sila, dapat at least 200 yung may ship daily. So, at least, ibig sabihin, 100 pataas to. Ito, 80 pataas, 200 pataas. Yan. So, pwede natin i-combine yung A and C. Tapos, pwede din natin i-combine yung B and D. So, ito na siya, pag-combine na. So, yung LP model natin. So, yung profit natin. So, i-maximize natin yung profit, which is negative 20x plus 50y. Bakit negative 20x? Kasi yung profit natin sa scientific calculator is 20 pesos loss. So, loss, so negative siya. Tapos, 50 pesos yung profit natin sa graphing calculator. So, yan yung objective function natin. Then, we have yung constraints. Ito yung mga kaninang nakita natin. So, yun yung LP model for example 1. Next, for example 2. So, same din yung gagawin natin sa example 1. So, a farmer can plant up to 8 hectares of land with rice and corn. He or she can earn 5,000 pesos for every hectare planted with rice and 3,000 for every hectare planted with corn. Use of a necessary fertilizer, however, is limited by the credit cooperative policy, which says that only 10 gallons of the fertilizer should be delivered to the entire 8-hectare land. Rice requires 2 gallons of fertilizer for every hectare planted, whereas corn requires only 1 gallon per hectare. How will the farmer compute for the maximum profit he can make? So, or in other words, what should be the objective function? Also set up the constraints for the problem. So again, ano yung kailangan natin dito? Mina-maximize natin yung profit natin. Okay? So ano yung mga variables natin for profit? Okay? So now dun sa problem natin, since meron lang tayong So first, meron lang tayong up to 8 hectares of land. So meron lang tayong 8 hectares. Ibig sabihin, kapag magtatanim tayo ng rice tsaka ng corn, hindi tayo pwedeng lumampas dun sa 8 hectares. So for rice, yung every hectare ng rice ay 5,000 yung profit natin. And for every hectare ng corn, 3,000. So kung ilalat natin na X yung rice at Y yung corn, meron tayong 5,000 X tapos 3,000 Y na profit. So yung objective function natin is P equals 5,000 X plus 3,000 Y. Okay? Ayan. Next yung constraints natin. So ano yung mga limitations natin dito? So yung fertilizer, meron lang tayong 10 gallons for the entire land. And yung rice, kailangan niya ng 2 gallons for every hectare. At yung corn, 1 gallon per hectare. So dito, meron tayong 2x plus y is less than or equal to 10. Okay? Next, again, balikan natin yung 8 hectares ng land. So, ibig sabihin, yung maitatanim mong rice tsaka corn, less than or equal to 8. So, x plus y less than or equal to 8. So, yung una is yung limitation ng fertilizer. Kasi 2 gallons for rice, 1 gallon for corn, and limited ka lang to 10 gallons. Yung pangalawang constraint natin, ito yung number ng hectares para sa rice, tapos si Y yung para sa corn. Hindi ka pwedeng lumampas ng 8 hectares. Okay? So yun na yung, pag pinagsama-sama na natin yun, yun na yung LP model natin. Okay? So ganun construct ng isang linear programming model. So next naman, since alam na nating mag-set up ng mga LP models, ang kailangan naman nating gawin is to solve yung mga sinet up natin na LP models. Okay? So paano natin siya isosolve? So yung first solution is using the graphical method, and yung other solution is called the simplex method. Okay? And meron pa tayong third na solution, pero ito na yung gagamit ka ng computer software. Okay? Pero kung konti lang naman yung lines mo or konti lang yung constraints mo, pwede mo namang gamitin yung graphical method. Pag mas madami kang constraints, siguro pwede kang gumamit ng mga mas advanced na methods. Pero usually yung graphical, combination na din siya nung graph tapos ng algebraic na solution. Okay? So, paano natin masosolve yung isang LP problem? So, meron tayong fundamental theorem dito. If a linear programming problem has an optimal solution, then there is always at least one extreme point or corner point solution of the feasible region. A linear programming problem with bound non-empty feasible regions always contains optimal solutions. So ano yung sinasabi niya? Kapag drawing mo yung graph ng mga constraints mo, kapag merong solution yung LP problem mo, mahahanap mo to doon sa mga extreme points or doon sa mga corner points nung region mo. Okay? So, titingnan natin yan mamaya. So, definition. So, yung equation natin for a line. So, we have y equals mx plus b. So, we have linear equation in two variables. So, straight lines lang yung mga ginagamit natin dito. Okay. Yung mga unang examples, recall lang ng pag-graph ng mga linear equations. So, kapag mag-graph kayo ng equations, pwede kayong gumamit ng table of values. For example, y equals 3x. So, paano natin siya i-graph? Gagawa tayo ng table of values. So, if x is 0, then 3 times 0 is 0. So, pag x is 0, si y is also 0. If x is 1, then y is equal to 3. So, usually, kailangan mo lang ng 2 points para ma-determine yung line. So, kapag meron ka na ng dalawang points, i-connect mo lang sila gamit ang ruler. Tapos, pwede mo nang i-extend yung line na yun. Okay? So, 2 points determine a line. Pero kung gusto niyo na mas accurate ng konti yung graph nyo, pwede nyong dagdagan yung number of points na kinukuha ninyo. So, dito sa examples, 3 yung points na kinuha nila para lang sa accuracy. Pero same lang naman kung 2 points lang. Okay. So, simple recall lang siya ng pag-graph ng mga lines. So, proceed tayo sa pag-graph ng linear inequalities. So, linear inequalities naman, ito na yung mga equations natin na may greater than or less than. Okay? So, tingnan natin yung example natin. So, first, now we have 3x plus y equals 3. Okay? So, gagamit lang tayo ng table of values para makuha natin yung line natin. So, yung graph ni 3x plus y equals 3 ay ito. So, observe na yung line natin. Hinahati niya yung xy plane natin into 2. So, meron doon sa left nung line. Meron doon sa right side nung line. Okay? So, next. Yung equation naman natin dito, or inequality, is 3x plus y is less than or equal to 3. So, iniba lang natin itong equal sign ng less than. Okay? So, paano natin malalaman kung aling side yung may yung less than? So, gagamit tayo ngayon ng test point. Yung test point na yun ay ang magsasabi sa atin kung saang side nung line magiging totoo yung inequality natin. Okay? So, pwede kayong gumamit ng kahit anong test point, pero ang pinakamadaling gamitin is si 0, 0 or yung origin. Kasi kapag isa-substitute niyo siya doon sa inequality, hindi niya na problema yung mga multiplication. Okay? So, sa example natin, yung point na ginamit natin is -2, -2. So, doon sa graph, nandun siya sa kaliwa ng line natin. So, kung isa-substitute natin si -2, -2, so ito si x and y coordinates natin doon sa inequality natin, makukuha natin tong -8 is less than 3. Now, is this true or false? So, -8 less than 3 is true. Ibig sabihin, kung true siya, then yung side kung nasaan yung point na ginamit natin, yun yung feasible region natin or yun yung i-shade natin. Okay? So, ibig sabihin, lahat nung nandun sa side na yon, since true yung inequality, uh, true siya kahit aling point doon. Okay? Next. Makikita nyo yung line na mga dash line siya or dotted line siya. Bakit siya dotted line? Kasi yung inequality natin is less than 3. Kapag less than or greater than tapos walang equal sign, hindi kasama yung line mismo, kaya dotted line. Okay? So, take note nyo yung graph na ganun. So, next, okay, so yung next natin is 3x plus y greater than 3. So, kung kanina less than, yung greater than naman, and syempre yung kabilang side. So, yung test point, again, pwede kayong gumamit ng kahit anong test point. Pero ang pinaka-recommended nga talaga is yung 0, 0. So, for example, ginamit natin si 0, 0 dito. Okay? So, asan si 0, 0? Nandun siya sa left side ng line natin. So, kung 0, 0, magkakaroon tayo ng 0 is greater than 3, which is false. Ibig sabihin, kung nandito si 0, 0, so kung nandito si 0, 0, at false yung inequality natin, ibig sabihin, ang i-shade natin, yun nandun sa kabilang side. Okay? So, yun yung gamit ng test point natin para malaman natin kung aling side yung magsasatisfy nung inequality. Okay. So, next. Yung next example natin, so sketch the graph of the following inequalities to determine the feasible region. Okay, so meron tayong 4. So yung pinakamadali yung x is greater than or equal to 0 and yung y is greater than or equal to 0, which is yung x and y axis lang. Okay, since may equal sign, then solid yung line natin. Okay, next, yung x minus y greater than or equal to 0. Okay? So, yung x minus y greater than or equal to 0. So, first, hanapin natin yung line. Saan siya doon sa graph natin? So, i-consider natin yung x minus y equals 0 or x equals y. Okay? So, if x is 0, y is 0. If x is 2, y is 2. So, ito yung line na x minus y equals 0. Now, yung given sa atin, less than or equal to 0. Okay. So, hahanapin natin yung region niya. So, either doon sa taas or doon sa baba. So, gagamit tayo ng test point. Okay. So, pwede ba natin gamitin si 0, 0 dito? Sa case na to, hindi. Bakit hindi natin siya pwedeng gamitin? Kasi, andoon siya sa mismong line. Okay? So, hindi kayo pwedeng gumamit ng test point na nandoon sa mismong line. So, kailangan yung gumamit ng ibang point na wala doon sa line. So, dito nagkataon na yung line natin ay dadaan kay 0, 0. So, hindi pwede si 0, 0. Likewise, hindi nyo pwedeng gamitin si 1, 1, 2, 2. So, gagamit tayo ng ibang point. So, try natin si 1, 4. So, nasaan si 1, 4 dito? So, 1, 4. Andito si 1, 4. Okay. So, si 1, 4. So, substitute natin sa inequality, we have 1 minus 4 less than or equal to 0. So, we have negative 3 less than or equal to 0, which is true. Ibig sabihin, yung side kung nasaan si 1, 4, yun yung shaded part. So, yun yung region na hinanap natin. Next, yung last na inequality natin. So, again, hahanapin natin yung line. So, table of values lang. So, if x is 0, then y is 7. If x is 8, then y is 1. Okay. So, pwede kayong gumamit ng ibang points. So, pag graph natin siya, ito siya, yung line na ito. Okay. Now, again, kukuha tayo ng test point. Okay. So, yung ginamit dito sa example is 2, 5. Now, pwede na natin gamitin dito si 0, 0 kasi wala naman siya doon sa line ni 3x plus 4y minus 28 equals 0. Okay. For purposes ng example, so sige, si 2, 5. Pag sinubstitute natin si 2, 5, we get negative 2 less than or equal to 0, which is true. So, yung shaded part ay yung nasa baba ng line. Kasi nandoon si 2, 5. Okay? So, yung feasible region natin is itong shaded part na ito. Okay. So, proceed tayo ngayon sa example na solve na natin yung LP problem. So, yung example natin dito is yung example natin kanina, yung sa rice and corn. So, meron na tayong LP model dito. So, now, i-graph natin siya. So, kapag graph natin yung mga equations natin, so, makukuha natin to. So, first, si x plus y equals 8. So, nasan si x plus y equals 8. Tayo ng ibang kulay. So, ito si x plus y equals 8. Okay? So, equation natin, ang hinahanap natin is x plus y less than or equal to 8. So, kung yun si x plus y equals 8, so gagamit tayo ng test point. So, pag 0, 0, we have 0 less than or equal to 8, which is true. So, ang shaded na part natin is yung nandito sa baba. Okay, next. Yung other equation natin is 2x plus y is less than or equal to 10. So, si 2x plus y equals 10 ay yung other line. So, again, test point, si 0, 0. 0 is less than 10. So, true. So, ang shaded part is yung kung nasan si 0, 0. Kung nasan yung test point na totoo. So, yan. So, makikita natin dito sa figure natin na yung region natin ay ito. So, ito yung part na totoo lahat ng inequalities natin. So, ito yung feasible region. Now, sabi doon sa fundamental theorem kanina, mahahanap mo yung optimal solution doon sa problem sa mga corners ng feasible region mo. Okay? Now, yung region natin, meron tayong apat na corners. So, we have 0, 0, we have 5, 0, we have 0, 8, and we have 2, 6. Okay? So, usually makikita nyo naman yan doon sa graph kung saan nag-intersect yung mga lines ninyo. Pero kung hindi obvious, pwede nyo siyang isolve. So, tulad nito. Since nag-intersect si x plus y equals 8, tapos si 2x plus y equals 10, pwede nating hanapin yung point of intersection nila. So, meron tayong systems of linear equations in two variables. So, pwede tayong gumamit lang dito ng elimination or substitution. Isosolve natin yung x and y kung saan sila mag-intersect. Okay? So, pag nahanap na natin yung extreme points natin, so yun na lang yung mga gagamitin natin para i-test doon sa objective function natin. So, isa doon sa apat na yun, since apat yung points natin, yung magbibigay nung optimal solution. So, isa-substitute lang natin lahat ng points na yun doon sa objective function natin at makukuha natin to. So, yung pinakamataas, since nagma-maximize tayo ng profit is si 28,000. So, therefore, yung maximum profit natin is 28,000 where 2 hectares yung ginamit sa rice and 6 hectares yung ginamit doon sa corn. Okay? So, yun yung solution natin. Okay? So, another example, ito naman yung sa example 1. So, meron na tayong setup nito ng LP model. So, i-graph na lang natin siya. So, the first, x is between 100 and 200. Okay? So, kapag x equals 100, meron tayong vertical line sa 100. Pag x equals 200, meron tayong vertical line sa 200. Since yung x ay nasa gitna ni 100 at 200, so shaded part natin yung gitna. Same din kay y. Si y naman, pag y equals 80, meron tayong horizontal line kay 80. At meron din tayong horizontal line kay y equals 170. And kukunin natin yung gitna nila. And yung last na inequality natin, x plus y is greater than or equal to 200. So, ito yung line na yun. And since greater than, again, kukuha tayo ng test point. So, makikita natin na ang feasible region natin ay itong dark na part. Okay. So, doon sa figure natin, Yung feasible region natin, meron tayong 1, 2, 3, 4, 5 na points. Okay? So, meron tayong 280, 200, 170. Meron tayong 100, 170. Tapos, meron tayong 100, 100, tapos 120, 80. So, paano nakuha yon? Yan. So, para lang clear. Yung line na to is si x plus y equals 200. Para makuha natin yung intersection dito, ito ay si x equals 100. Okay. So, substitute lang natin dito. So, we'll get 100 plus y equals 200, which is y equals 100. So, yung point dito ay si 100, 100. Yung isa naman, si point B. So, ano yung dalawang lines natin doon? We have x plus y equals 200 and si y equals 80. So, we have x plus 80 equals 200. We have x equals 120. So, 120, 80. Yung point na yon. Okay. So, meron na tayo ng mga points natin. So, substitute lang natin siya doon sa objective function natin. So, pag na-substitute na natin siya, since maximize yung ginagawa natin, hanapin lang natin yung pinakamalaking profit. So, this time, yung point E, which is 100, 170. Therefore, yung maximum profit natin, pwede is 6,500. Given that 100 na scientific calculators and 170 na graphing calculators yung gagawin daily. Okay. So next example, same process din yung gagawin natin. So kailangan first may set up natin yung LP model natin. Once na na-set up natin yung LP model, pwede nating i-graph yung constraints natin. After nating i-graph yung constraints, mahanap natin yung feasible region natin. Kapag nahanap nyo na yung feasible region, kukunin nyo naman ngayon yung mga extreme points. So, yung mga extreme points ay yung mga corners ng feasible region. Para makuha yung mga coordinates ng points na yon, kukunin nyo lang yung intersection ng dalawang lines na dumaan doon sa point na yon. Okay? Now, pag na-identify nyo na lahat ng extreme points, isa-substitute nyo lang siya doon sa objective function para makuha nyo yung optimal solution natin. So, kapag hinahanap is maximize, usually sa profit, pag profit is maximization, yung pinakamalaki. Kapag minimize naman, yung pinakamaliit. Okay. So that ends our discussion on linear programming.